Alright, what's poppin' guys? So today we'll be doing longest repeating character replacement, which is a medium question. So the question says that, given a string s and an integer k, we can choose any character of the string and change it to any other uppercase English character, and we can perform this operation at most k times. So let's just see what the question is really about, because it's a lengthy description. So what all they're trying to say is that, let's say we're given this string, right, AB, and given k equals to 2. 2 meaning we can actually replace up to 2 characters in this string. So why would we want to replace the characters? Because we're trying to create the longest consecutive substring, meaning that we want the string at the end to have the longest consecutive, meaning it'll be A, right? So it's the same letter, repeating character, right? So if we replace these two B's with A's, at the end will be A, right? So it's the same character being repeated 4 times. So we want to return 4. So that's the longest possible substring, repeating substring being able to be created after replacing it at most 2 times. And vice versa, we can replace the two B's with we can replace the two A's with B's, and then we form B, which is also a valid repeating substring, but the length is also 4. So we actually just want to return the length of the longest repeating substring after replacing it at most 2 times. Let's take a look at another example 2. So given this string, we are allowed to replace at most 1 time only. So what is the longest repeating substring that can be formed? Let's say we can replace this B with an A, and then this will be formed A, which is the longest repeating substring that can be formed by replacing 1 character. And vice versa, we can replace this A with a B, and it will be formed B, which is also length 4. So that's basically what the question is trying to ask, right? So let's look at this example to really walk you through how we can solve this question. We're going to be solving this using a sliding window technique. So this will run in a linear time, O of n solution. So how do we actually solve this? There's three parts to this solution. So it's the first step I'm going to talk about the sliding window. What we observe is, a window is basically formed when we have 2 pointers. So a window is formed when we have 2 pointers, and the window is bounded by the 2 pointers. So if we have the left pointer here and the right pointer here, so the left pointer is going to have an index 0, and the right pointer is going to have an index of 3, right? The window form will be these 4 characters, so AACA. And to find the window length, we actually take RP, right? RP minus LP plus 1, right? Because we observe 3 minus 0 plus 1, so this actually gives us the correct length 4. And the reason why we must have a plus 1 here is because it's 0 index base. Therefore, to get the correct window length, we have to do RP minus LP plus 1. So we're going to see how this window length is going to come into play later on. But let's go back to this window thing, right? What we're going to do is, we're going to try to slide through the window throughout the array, and we're going to see if this window is valid. Valid meaning, are we able to replace up to 2 characters to make this a repeating substring? So let's just look at this window for starters. AACA. Are we able to replace up to 2 characters to make this a repeating substring? Yes, we are. We are able to replace this C with an A, and this will form AAA, which is a repeating substring. So we will say that this window is valid given the constraint that we are able to replace up to 2 characters. Okay, so actually how do we determine if the window is valid? So we have the 2 parts of the solution now. We do the sliding window, right? And then we have window validity. So checking if the window is actually valid. So valid meaning we are able to make it a repeating substring. Validity. Okay, let's hope I spelled that right. Okay, so to check if it's able to make it a valid window, we're gonna keep track of the character count. So let's look at this sliding window, right? This window. How many times does A appear? A appears 3 times, and C appears once. If we want to replace a character, should we replace the one that occurs the most frequently or the least frequent? Of course, we want to replace the ones that occurs least frequently. Because if you are able to convert all the characters that's least frequently appeared into the character that's most frequently appeared, that will make the best use of our replacement numbers and to form the actual correct valid repeating substring, right? So in this case, we don't want to replace A because we are only given 2, right? We don't want to waste these 2 on replacing the character that appears the most often. We want to focus on changing the characters that appears the least often. In this case, in this window, it'll be C. So we're gonna look at the characters that appears the least often, and we're gonna see if we have one least occurring character, right? Are we able to replace it? Yes. So let's take a look at this example where we have this window over here. So we're going to do this algorithm where we look at the window length. So this window length will be 5. And we're going to see what is the most frequently occurring character. It will be A, right? So in this case, A appears 3 times, C appears once, and B appears also once. We're going to see, okay, the window length is going to be 5, right? Okay. And the most occurring character appears 3 times. A appears 3 times, right? And we take 5 minus 3 equals to 2. So what does this 2 really represent? This 2 represents how many times does the least occurring characters occur basically. So we can see that it only occurs twice. So we have this C and B. So this 2 represents a C and B. So if we take the window length minus the most occurring character, we are left with the number of characters we need to replace. So this 2 represents the number of characters we need to replace to make this into a repeating substring. Therefore, we just need to check. After taking the window length, so we take the window length, and we minus the most frequent character count. Is this less than or equals to k, right? So if this is less than or equals to k, meaning that we have enough replacement opportunities to replace the least frequent characters, right? So if this is valid, so if this formula is valid, then we can know that this window is valid. And if the window is valid, we're going to keep a max length variable. So the max length variable is just going to be the answer, right? So it's going to be initialized to 0. And every time we find a valid window, we're going to update the max length. So if the window length is bigger than the max length, then we know that yes, this is correct. We can update the max length to be 5. So the 5 is the window length. Because we found that this window is possible to form a repeating substring given 2 replacements. Right. So let's look at another example where it's not a valid window. So let's look at if we move the RP here. Is this valid? This window is not valid. Why? Because we can see that B appears twice. So we gotta keep the character count. So B appears twice, right? So 5 minus the window length now is 6, right? The window length is 6 minus 3. So we want to delete off. We want to delete off the most frequent characters, so to see which are the characters that we need to replace. So we need to replace these 3 characters. But are we able to replace 3 characters? No, we only have 2, right? So we find that the window length, so look at this formula, the window length is 6 minus the most frequent character is 3. This equals to 3, which is not less than or equals to k, right? So we are not able to replace 3 characters to make this window all A's. Therefore, we can say that this window is not valid. Right. So if the window is not valid, we want to move the left pointer forward until it becomes valid again. So in the code, we'll probably have a logic to basically say, while the window is not valid, we want to move the left pointer forward until it becomes valid. In this case, if we look at this window, it's not valid, right? So we'll move the left pointer forward, and then now we check, is this window valid? So in this case, we have 2 A's and 2 B's, right? So if it's 2 A's and 2 B's, either one will work. So the most frequent character is still 2, right? So we're going to take the window length, in this case is 5, minus the most frequent character count, which is 2. This equals to 3. So what I was trying to say is that within this window, we need to replace at least 3 characters to make this whole thing into a repeating substring, which is not possible. So 3 is not less than k. Therefore, this window is still not valid. Therefore, we have to move the pointer forward once again. So this is the logic. Okay, and the last part is basically, the last part to the solution, number 3 here, is to keep track of the character count, right? So how are we able to keep track of this most frequent character, right? So the one way is to basically, every time we have a new window, we repopulate the entire character count dictionary, and then we have to go and loop through the whole character count dictionary to find the most frequent occurring character, right? And that operation will take us O of 26. Why? Because each dictionary, in worst case scenario, there might be A equals to 1, a B occurs 1 time, and all the way up to Z, right? And we know that there's 26 of these characters in the English alphabet. And to find the maximum count, the algorithm will have to traverse through 26 times, right? To populate and also find the most frequent character out of the character set for a specific window. That's in the worst case scenario. And we know that a pointer, right, the sliding window, it will slide through n times. Right, so this could slide through at most n times. So therefore, for every sliding window, if we are repopulating and keeping track of the most frequent character, this algorithm will run in O of 26n. So 26 is the checking of the most frequent character, and n is the moving of the window. So it's still a linear time solution, right? So instead of actually repopulating, there's another method. It's basically we keep a global character count. So we have a global character count, and at first we're gonna initialize it with just initialize it to just LP and RP here. So we're gonna have a global character count. We're gonna initialize it just to be A in the first place. So we're gonna look at the right pointer and we're gonna add A, right? It's gonna be 1. So every time we move the right pointer or left pointer, we update the global character count dictionary. So instead of repopulating the entire dictionary every time we find a window, we just need to update the dictionary every time we move the pointers. So that's a bit more efficient in that case. So if we were to move RP once, we will just take the character and then increment the count by 1. So in this case, moving RP will get us an A. Then we can update A to be 2. And if we move LP forward by 1, we're going to take the character it was on and minus 1 from it. So this will become 1. So every time we move the pointers, we must remember to update the global character count. And from this global character count, we can get the most frequent character count. So this is how we're going to do it. So let's look at the code. It's going to be more clear once we look at the code and then you understand the solution. So for the first place, we're going to keep a max length variable of 0. So this is going to be the result to return at the end of the function. So every time we have a valid window, we're going to update the max length. And then we have a left pointer initialized to 0, right? And then we have the global character count dictionary. So we're going to start looping through the array. So for RP, for right pointer in range, the length of the whole string, right? So what we're going to do first is, remember, let's say we start in this position, right? We start in this position where LP and RP are at the first character. We want to first add A. We're going to first update A into the dictionary. So we're going to look at the current character. So the current character is going to be S at RP. So it's going to be just A in this case. And then what we're going to do is, we're going to update the character count dictionary. So the character count at the current character is going to be the character count dot get current character 0 plus 1. So what this does is basically it just it looks at the character, and looks at the dictionary. If the character does not already exist in the dictionary, it initializes to 0. So in the first place, like when we start here, right, there's gonna be nothing in the dictionary because it's an empty dictionary, right? But we want to initialize A to be 1. So what we're gonna do is, it's gonna set A to be the current character count frequency or 0. So this will default to 0 if we don't have we don't have the current character in the dictionary. But if it already exists, then we're gonna take the current character count. So it's gonna default to 0 and then add 1 to it. And with that, we're gonna then take we want to basically find whether the window is valid. So how do we check the window validity? We take the window length, right? So the window length is gonna be RP minus LP plus 1, right? And then we want to check, wow, the window length minus the max of the character counts dot values. So we're doing this formula right now. We're going to take a look at the window length and want to find the most frequent character count. So to find this most frequent character count, we can do the character count, which is dictionary. We get all the values. So these dot values will basically take all the frequencies from the dictionary. I want to find the maximum, right? So this will basically evaluate to the most frequent character count. I want to check, well, this is bigger than k. So according to this formula, if it's less than k, what I'm saying that is we have enough characters to replace to make it a valid repeating substring. However, if it's bigger than k, it's saying that this window is not valid. So remember, if the window is not valid, we want to move the LP forward, right? So we want to move left pointer forward by 1. And remember, every time we move the pointers, we must update the global character count. Therefore, before moving it, we're going to take the current character dictionary. We want to take the character at the left pointer and want to decrement it by 1. Right? So it's basically saying that before I move the LP forward, I'm going to take A within it, and we're gonna try to decrement it by 1. So minus equals to 1. And after we decrement it, we can move the left pointer by 1. So after we get out of this loop, right, basically we know that this is a valid window. So then we can update the max length. So max length, so before we exit, right, we want to basically update the window length equals to RP minus LP plus 1, right? Because we updated the LP, but we still need to update the window length to make it correct. Window length. And then at the end, max length equals to the maximum of max length and the window length, right? So if the valid window length is bigger than the max length, then you update. And then at the end, we can just return the max length and we can run this code and you can see that it passes. So this will run in O of 26n, which is still a linear solution. So I hope that this helps you. So it's a tricky part. The tricky part is understanding the sliding window technique and actually this formula. So if you can look at the question and understand what technique it uses, in this case sliding window, and you can also find the formula to see if the window length is valid, then this question will be manageable. So I hope that has helped you. Thank you so much for watching.